All right, in this lesson right here, what we're going to do is take a look at creating the Fireball class and the Mage class. So this is where we're going to do several things, actually. This is where we're going to extend or inherit from character, which, if you remember, inherited from Sprite.
Mm-hmm.
And now we can take that character and we can start breaking it up into a fighter, into a mage that can shoot out spells, and into the special Joel character that just really runs into a corner and hides.
It goes, ah!
Exactly. That's all it does, is screams and dies. But this is where we can easily get all of this ability. Another thing, of course, is with our mage, it's going to need to be able to fire spells, and in our case, we're going to do the Fireball class. So we'll have a Fireball that we can introduce into the level. And then with those two things, we also need to make sure we concern ourselves with the Fireball being able to actually kill a monster. And, well, if we can kill them, it would be only fair if they could kill us, right? So with that, Joel's given some sign language right now, asking if he could talk. So, yeah, okay, go ahead, Joel. What do you want to add to this?
All right. Actually, I didn't really have anything to add.
So you just wanted me to shut up.
Yeah.
I understand. Okay, so go ahead. Let's look at the big picture first.
Okay, so basically we're going to create the Fireball class first, which just defines a simple sprite, so we're going to inherit from the sprite class, and all it does is move our sprite over time in the specific direction that we've told it to move in.
Yeah, we're going to say, hey, move left, and it's just going to do its little job and move left.
Right. And then we're going to, from there, make the Mage class, which is going to extend from the character, and it'll give us the ability to shoot a Fireball. So therefore, we're going to need to improve the key press functionality so that when we press the spacebar,
we can shoot the Fireball.
We can shoot the Fireball. And then we'll create a protected function that just creates the Fireball. So key press is going to actually cast the spell. It's going to call the cast spell function. And it'll also add it to the list of NPCs, so that we'll call its idle update function.
Yep, and so it'll join the list with all the other enemies and be updated.
Right. And then we're going to have to do some finishing touches. We're going to have to reset the position of the character if we're killed. So if our character dies because the enemy touches us, then we're going to have to reset to position 1-1. And from there, if we're going to have to add the enemies killing the character inside of the enemy's move function. So when an enemy touches a character, we have to die.
The character has to
die.
Yeah, the character has to be reset to the position.
And then we're going to have a little bit of a memory leak little problem that we had. If you play the game entirely, it's not going to matter because we killed all the enemies. But if we don't do that, we need to delete the memory that we have. So let's go ahead and switch over to .NET and start implementing this stuff.
And it really won't be that big of an implementation.
No, this is going to be easy.
Yeah.
Compared to what we've been doing, wow. So let's go to header files and add a new item.
So we're going to do the Fireball class first?
Yes, we are. So Fireball. All right. So inside of here, our rule, if not defined, Fireball _age. And we're going to define Fireball _age. And, of course, we're going to have our end if.
Yeah.
So let's define our class. Class Fireball. And he's going to be public.
Public.
Public Sprite. Which means we're going to have to know about Sprite. So we're going to say include sprite.age, right?
Yep.
We're also going to say, public protected.
And while we're doing that, let's add our semicolon at the end of the class.
Yep.
There you go.
Whoa. All right. So, our constructor, Fireball. We're going to have our level, not draw engine, level. Then we're going to have our draw engine.
Again, we're doing the constructor arguments, which are pretty much going to follow with every other constructor argument we've done, except we will be adding something special.
Something special. And continuing, float XDIR. What this allows us to do is set the initial direction of our Fireball, which is important. Isn't it, Dan?
Yes, it is, because we want to be able to specify, do we want it to move up, do we want it to move left, right, up,
or down?
Or down. Yep. I said it up twice, I guess.
We could, in fact, even specify him to go diagonally, but we won't.
Yeah, but we won't, because the character can't actually move diagonally.
Right.
So when the mage decides to fire a Fireball, it's going to fire in the direction that the mage is currently pointing.
Yep.
But we're not worried about that right now.
Right. So we also have our void idle update. Dink with void. Now, that's all that we need for this, because remember, we already have our facing direction vector, right?
Yep, it was defined inside the sprite class.
That's right. So at this point, we just need to create our source. Dink, come into here, Fireball. All right, so now let's create these balls. So inside of here, we have our include Fireball, and we're just going to create the constructor, right?
Yep, we're going to actually do the implementation for it.
Right. So, Fireball, and type all
Lots
this out
of typing again. Yeah, we could have cut and paste, but then we would have had to do some deleting and
changing.
Yeah.
And all that stuff.
Yeah.
We don't want to do that, do we?
Yeah.
No.
Let's put a float in here. That kind of makes things better.
Yeah.
Alright, so there we have it. Now we're going to call our sprite constructor, as we did before, and pass it lev de s underscore index x, y, and finally I underscore lives. Did I get all that right?
Yeah, you did.
Okay,
yep.
Awesome. So inside of here, we're going to say facing direction, dot. Now I think, because I did not get what I was looking for, did I spell that wrong?
Yeah, you probably did.
You know what? Let me just do this real quick. Yeah, my bad. Never mind. Didn't mean to do that. So if we go back to our sprite.h file for a second, and let's scroll down to the bottom here, we have facing direction. Let's copy this because I keep forgetting how I spell things. So inside of here, it's going to simply be facing direction dot x equals x dir, which was passed to us, and then facing. Of course, I can still paste it, but I like typing, so there.
There you go.
And we also need to set our class ID equal to Fireball class ID. Then we need to say void. This is going to be our idle update function.
Yes.
This is the only thing that we need to implement. So Fireball, and then idle update, dink, and void.
And this is where the fireball is just going to keep moving in its direction.
Right. So we're going to need to also make sure that we move in the correct direction, right?
Yes.
So we could, of course, just say move, right?
Yeah, but we need to actually make sure that we don't hit a wall by any chance.
Right. So in this case, we're going to say if move, so to make sure it works right.
Yeah.
Now, there's two ways. We could just say the direct move function, but to specify that we're definitely calling the sprite class's move function.
Yes.
Right. We're going to say sprite, and then the scope operator, like we talked about before, move. So that makes positive that we're definitely moving in the right direction. So I keep typing direction. I don't know why. So facing direction.x and facing direction.y. Right?
Yes.
Yes. So inside of here, we're going to have to add this into, well, what we're going to need to do is make sure that we don't, if we hit any of the NPCs, then we need to kill them, any of the enemies, right?
Yes.
We need to make sure if we hit an enemy, we need to kill that enemy.
Yes.
That makes sense. So inside of here, we're going to declare our iterator.
So we're going to look through our list of NPCs and figure out if it is an enemy, and if we happen to hit it, then it needs to go away.
It needs to die. So for iter equals level npc.begin, and then iter does not equal level npc.end, just like we did before, and then iter plus plus. Now inside of here, what we're going to do is say if all we need to check for is that is the one we're currently looking at an enemy, and is it at the same position that we're currently at?
Yes.
So the first thing is, are we of type enemy? So star iter class ID, so the one we're looking at, let's make sure it's not a fireball. So we're going to say does not equal our ID, right?
Yeah, the idea behind this is if we're a fireball,
we can't shoot another fireball.
We can't shoot another fireball.
Right, we're just trying to shoot enemies. I mean...
Yeah, we're just trying to shoot enemies.
So, also, we want to make sure that iter... I can get it one of these days. Get x equals us, position.x. But again, both of these are going to be floats, right? So we're going to have to cast these both over to ints. And why is that, Dan?
Well, it's that whole rounding issue. If we're at position 2.5 again, and say the enemy's at position 2, well, what's going to happen? We won't be equal to each other.
That's right.
So if we cast it as an int, then we'll get the 2.5 to become 2.
That's right. So I think that's all we have for that if statement there. So just checking the x and y. And at this point, all we want to do is say iter Now, what are we influencing now? This is an enemy. We know this is an enemy, and we know that the fireball is at the same position as this enemy.
Yes.
So we need to remove one of its lives.
Well, actually, technically, this is what the interesting part of the system is. Technically, we're looking at sprites.
We're looking at sprites.
And they're on a list. Currently, the only sprites that we have in our level are enemy or fireball.
Right.
But let's say we happened, instead of, say, an evil monkey, we make ourselves an evil Iceman.
Yeah, or anything.
Or anything. The fireball will actually respect that because it hit a sprite that wasn't a fireball.
Right. Which is very, very
Which
cool.
is really neat.
Yeah,
it makes
very
it
cool.
very extendable.
So we remove one of its lives, which is its only life, and then we remove a life, our life, so that we die. So, because if a fireball hits something, we don't want it to continue moving. We want it to just end.
Yeah, it vaporizes as soon as it hits the enemy.
That's right. So if he can't move towards that direction, what does that mean? We've hit a wall.
Yeah, we obviously hit a wall.
So we want to get rid of ourselves so that we don't continue. Because if we hit a wall, we die. We go away. So add lives, -1 to ourselves.
If this was a really cool game, we could say it scorches the wall and...
yeah, sure.
Yeah, but since we can't do that...
No,
it's
so we're not going to.
No.
So another thing that we want to make sure is if we try to compile this right now...
We should get some errors.
We should get some errors.
Fireball class ID we did not define in our enum.
So if we go over to... Where do we define that?
Class ID.
Fireball, right here. Thank you.
You're welcome.
Fireball _class ID. So now that's 4.
So that's 4.
So that's going to get rid of that error. Cannot access private member, protected member in class sprite. Dun dun dun.
Well, if we go back into class sprite, you'll find out that is actually in a protected member.
Right. So
we could change it. We can make it public,
right,
and it would fix that problem pretty easily.
So let's go ahead and do that. So we've gone to sprite, and we'll notice this is protected.
Yep.
So we're just going to take this and put this over here so everybody can access it, right?
Yep.
And that's going to make everything fun.
Yep.
Does that make sense?
It's fine by me.
Okay. So with that, we should have... So with that, we should have our fireball class created. Now we can go ahead and create the mage, which is going to use it. So first thing, Buzz, what are we doing?
Probably adding a header file. Probably the mage.h file.
Wow.
Then you're going to follow your rule. Then you're going to set up your class. Then you're going to follow your second rule. That's just my guess as a student representing the student union.
Now, just as a student, Buzz,
yeah,
are you starting to feel a pattern about how we're making things, what type of functionality we're using?
Absolutely. Definitely following the workflow set out in project management in that lesson, which is really cool. And I love the way that all of this stuff is interacting. As a matter of fact, at the end of this lesson, we should definitely go back over to Photoshop, bring up the big picture, because at this point, everybody should become intimately familiar with all the boxes. And then when we put up the 5,000 arrows, everybody's going to go, oh, yeah,
that's where they all came
sense
from.
So, yeah, definitely. This is really cool stuff.
So let's go back over into character. I'm going to save myself some time. Go into the header, and let's just copy all of this right here. Go back to our sprite. And just copy this right here.
Go back to our mage.
Go back to our mage. That's what I meant to say.
Who is a sprite?
Huh? Who is a character.
Who is a sprite?
Right. And we also need to implement our key press. Key press, and we're going to pass it a character C. Inside of here. And inside of the protected, we're going to have a cast spell as we were talking about before. And this is also void. And finally, we're going to have a character spell key. So basically, what key do we have to press to shoot the spell?
And there's something that we're going to have to add into the constructor.
Our constructor right here.
To reflect
Actually, we'll put that right before the W key. So character spell _ key and equals. We'll just default to the space character. How's that sound?
That sounds good by me.
All right. So with that, let's copy this entire thing, and now let's create our source file. So create a new item, CPP. It's going to be our mage, and we're going to start out by including our mage.h, right?
Yep. And then we're going to start implementing the functions.
Implementing the functions. So mage,
and then you can paste your constructor thing.
Paste my constructor. We're going to have to change a few things, but not too much.
Just some deleting.
Which
is probably easier than typing.
I don't know, man.
There's a lot of things to delete.
The pain. Typing is so much more fun.
Yeah, it is. You're right. So why'd you copy and paste?
I don't know. So with that, let's put in our sprite call.
No, we want to do our
character call. My bad.
Because we want to use the functionality that's already existent from character.
Right.
Which Mage is derived from. So we're still good.
We're still good. X, Y, lives.
We won't do the spell key because that's not defined
in
character.
Down key, left key,
and right key. Enter, enter.
All right, so here we are. All we need to do is say spell key equals, which key? Spell underscore key, which is the one that we were just passed. And class ID. This is going to equal mage class ID student. Are we going to have to add that somewhere?
I would think so. Probably some sort of enum area. Probably back all the way up in the sprite. Yep.
Ah.
There you go.
So maybe something like mage class ID.
And what's the number of that?
5.
Yeah. But, again, it doesn't matter.
Yeah, exactly.
Again, it doesn't matter.
We just care it's there. We don't care about the number.
As long as it's there. So now that we can now declare our mage key press event. And we're going to pass the character C. And inside of here, what we're going to do is say val equals character key press. Now what we're doing here is saying when we press a key, did it return true or false? Did it allow us to move?
Yeah, because we're calling on the functionality that was defined inside of the character class, which the mage still has access to.
Right. That means if we pressed a space key, by default, would this val be true or false?
No, because the character... Well, it would be false.
It would be false.
Because the character only responds to W, S, A, and D.
Right. So if we can say if val equals false, that means we need to handle it at this point. So we can come in here and say if C equals our space key, our spell key. So equals our spell key. What we're going to do is do the following. Cast spell, right? Because we defined our cast spell. We haven't made the cast spell function yet.
Yeah, but
we will.
That's kind of misspelled.
Yeah, it is kind of misspelled.
According to convention, if you've noticed, we have a lowercase that begins the word, and then for every new word, it's a capital letter. Right. So it's just consistency.
It's consistency. We'll return true if we get to there. Otherwise, we'll just return the value that was passed to us. So simple as that. So now, final function for our mage is our cast spell. This is where we do the work, actually, in this function. In this class, actually.
Actually, yes.
So we'll create a fireball, because we've got that ready. So it's going to be a pointer. We're going to say equals new fireball, because we want to create a new one.
You'll notice this is just like we did with the enemy, when we said add enemy inside the level class.
That's right. So we'll pass it level, draw area,
S-index,
S-sprite, fireball. Which we are going to need to define.
Yep.
And we also have our position that we want to go to. So position.x plus facing direction.
That's so that when we cast a spell, it's not on top of the character.
Right.
So we want to cast it in whichever direction we are currently pointing. And that's its initial position. That's not how it's going to move. That's just where it is in the world.
And then we have our actual direction that we want to go, and that's just plain facing direction.
Yep.
So facing direction. This is getting really long. So that's all there is to it. Now that's one long line. In fact, if I were you, and I'm not you, but I'm me.
This is the way Joel's going to do it.
And at this point, we can just add this NPC into it. So add NPC. Isn't that nice that we have that function? And we're going to pass it. Let's cast it to a sprite and just pass temp.
Yeah, because again, a fireball is a sprite.
That's right. And we are going to need a few little things up in our header file here. We're going to need a character. I'm sorry, not a character, a fireball, because we are using a fireball. So fireball.h, right?
Yep.
And we're going to also need our level, because we are taking advantage of that as well.
That's right.
So let's compile this and get the 3,000 errors that are absolutely necessary. Alrighty, let's see. As I'm thinking here to myself, argument truncation value of that's just a warning. Okay, integer type int unexpected. All right, before I make any mistakes here, let me see. Dingy. Okay, in our mage header file, we should be including a few other header files as well.
Yeah, because we need to know what a character is
and what a draw engine is
and what a level is.
Right, all that stuff needs to be in here. Otherwise, well, we're going to have some problems.
Otherwise, our mage is clueless.
Right.
Yeah. And a clueless mage is bad.
That's really bad.
So there. Man. So there we have it. Now we have everything that should be functioning correctly.
Yep.
Now, if we look back at our big picture, we've got all of this. No way. So now we need to have our finishing touches. So we need to reset the position of the character if we're killed. Are we killed yet? No. So we need to make sure that is done as well.
So we need to make sure that the enemies can touch us and we go,
Yeah.
Yeah.
So if we go to the enemy.cpp file, so let's see, where are we? Right at this point right here, correct?
Yeah.
What we need to do is check to see if the player is touching this enemy, we need to run away.
Oh,
So-
no, we don't need to run away.
We need to die.
Yeah.
Yeah.
We need to kill the player. We need to remove a life from the player.
That's right.
Yeah.
So right after we draw it, we're going to say if the goals get X equals my X position, which is an integer, and goal get Y equals Y position, then we're going to need to say goal, you remove a life. So add lives, -1.
And that's about it.
Yeah, although one other thing that we want to check, this is a float, so we're going to have to cast it to an int.
That's true.
You know, this is one thing that's really, really important to remember, and it's very rare for a really good programmer to forget this kind of thing. So,
But it happens from time to time.
it does happen from time to time.
Joel.
Joel, just so everyone knows, he's pointing at the code, the stuff that I wrote, and well, I kind of forgot to do that, everybody. So,
that's funny.
but
okay.
you know, it happens. It happens,
happen.
and it's nice that it's caught. That's why you have groups and teams that can help you out.
That's right. So we do we just caught right now that the enemy is going to kill the character, right?
Yes, yeah, it will.
So at this point, we need to reset the position of the character if we're killed. So if we switch back to here, that would be in our character, right?
Yep.
So if we go into our character here, what we could do is, well, let's see. What would be the best way to handle this?
Well, in my mind,
Yeah.
what we have is the add lives function.
Right.
Right. And what we are passing to an add lives function when we remove a life is -1.
Right.
So why not inside of that function, when we remove a life, why don't we reset our position?
So that would be in the sprite class.
That would be in the sprite class, but we can overload it. We
So-
can from our inheritance, we can rewrite it into the character
So we
class.
could rewrite this for the character class.
Yeah.
So inside of here, we can say, well, let's see, how did we define this? Well, let's switch
let's
over
find
to the
out.
sprite, and let's go down to our add lives function. So let's just copy this right here.
And you'll notice it was defined as virtual.
Yes, so
which
we can't
means
overload
we
it.
are going to be able to overload it.
And we can remove, well, we can keep this right here like this.
Yeah, in case,
we can keep this
say,
right here.
Mage felt like rewriting
Right, someone
a
else.
life, or say if we derive something else later on.
That's right. So at this point, we can come into our character.cpp and implement this guy. So inside of here, of course, we can get rid of the virtual. And
Add in our
character.
character. Get rid of that default value because it can only happen in one place, which is the header in
That's
this
right.
case.
And then all we're going to need to do is say if num is, let's see, how do we want to do
Less than
this?
0.
No, not num, lives.
Lives.
Right. So lives plus equals num, right?
Yeah, I'm going to see where you're going because I was someplace else. But
You were
please
someplace
continue.
else, okay.
I was at, I think, the second step. You
Okay.
were at the first step.
So we need to check if lives is less than or equal to 0, right?
Mm-hmm.
Then we're going to say, well, no. I'm sorry. This is getting
Okay.
a little bit far away.
Okay. Let's just take this one step at a time. When we
Okay.
enter add lives,
Right.
we want to subtract a life from what we already have.
Or, well, we're adding a life.
Well, we want to add a life to what we already have,
Right.
which is actually defined in the sprite class, right?
Mm-hmm.
So we can call the sprite classes add life and pass it the value that we have.
That's true. So what we could do, my bad, guys.
That's all good.
So we can call sprite and then add lives. So this is what you're thinking, Dan.
And then we'll pass it num.
Right.
So
then at this point,
yeah.
we can say if lives is greater than 0. Because see, here's the thing. We're still alive. We
Yes.
want him, while he's still alive, to move back to the next 1-1 so that he has another chance.
yes.
Does that make sense?
But don't we already have a function called isAlive?
Yes, we do.
So why don't we just use that?
Good point. See, I'm thinking way ahead of myself. Or whatever.
Joel, there are two different mentalities that can go on with programming. One is you deal with the local variables. You deal with the variables directly.
Right.
And the other is that you make accessor functions.
Right. And both are good ways to do it.
Yes.
If you're dealing with more high-end type gaming, or I should say processor-intensive gaming, sometimes you want to just access your variables.
Yeah, if
not call a function. The extra overhead of a function can kind of start to build up after a while.
But in the case of this game, it's not going to matter, and it makes our lives a lot easier.
Yeah, it does. So if the sprite is alive, what do we want to do? We want to set his position back to 0, 0, right?
Mm-hmm.
So how would you like to do this, Dan, just to make you happy?
Well, we're going to have to set our variables.
Yes.
So we're going to have to set our position.x and our position y
equal to 1.
And then we're going to have to redraw the character, but also erase the character.
Right.
So why don't we just call the move function and move him 0, 0? So which means we're currently where we want to be. We don't want to move at all, but by calling this, we erase ourselves and then we draw ourselves.
So right in here we can say move 0, 0. Dink.
Dink, dink.
How's that?
Sounds good.
Sounds and looks good. So if we try to compile this, we get an error. Alright, so inside of here, cannot convert from float. This calls sprite void to int. Dink, 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 dink. Where am I not seeing? Oh, here. My bad. I forgot my little parentheses. I meant to do that. Okay, so this was just in our enemy.cpp. I forgot to put the little 2 parentheses in here, and both of my people forgot it, which is disappointing. Well.
Sometimes you miss the little syntax.
Yes, you do.
You know, you can't help it.
So back to the big picture here. We have one last thing that we need to do, and that's correct this Inferno memory leak that we have going on here.
Actually, I got one more thing to add to the list.
Okay.
But I'll see if you can catch it after we do the Inferno memory leak.
Oh, that sounds just great. So let's switch back over to our level.cpp. And in the destructor, we want to make sure that we kill every single NPC that's currently in our list.
Yeah, because we have a list, and each is allocated memory that it's pointing to. So if by any chance we happen to hit Q, we haven't finished the game, and we hit Q, we need to delete out the memory that we made.
That's right. So down here, if you remember correctly, if you remember incorrectly, then that's too bad. But inside of the update, we have this function right here that loops through and deletes the ones that are not alive, right?
Yeah, if we happen to die during the gameplay, then.
So if we can copy this same function into our destructor, and instead of this code right here, we're just going to delete everything that's inside. So we can just say delete star iter. So what is iter currently pointing at, which is the memory, which is an enemy or sprite, or fireball,
or something, and then we're able to delete it, which will give back our memory.
Right. So at this point, we can go ahead and go to our game.cpp and make it into a mage. So we can change character here into a mage.
Yeah, that's what I was looking for.
See, I remember stuff.
Yeah.
So we have our level, we draw engine,
But there's something else we need to do.
Yes, there is something else we need to do. We need to create a fireball.
Yes, we do.
You thought I'd forget, didn't you?
No.
You were hoping I would.
Yeah.
So sprite fireball. And what do we want this to be? Asterisk.
Yeah, because it looks like a fireball.
Yeah.
And there's one more thing we need to do.
All right, you got me.
Well, wouldn't it be nice to supply the mage with a space character? Did we do that?
That's default.
Oh, that's right. What about putting the mage class in the header instead of a character class?
We
don't have to.
No, we don't.
But it would be nice. Well, actually, we do have to if we want to fire fireballs.
Okay, before everyone gets confused, let's go to the game character.header right here, and game.h. And what we're going to do is include a mage.h. Just here.
And then scroll down.
And scroll down.
Player.
Yes,
type
player.
Character.
We're going to type mage.
Yeah.
Yeah.
Student,
works.
did that make sense?
Yeah, that's good.
Yeah.
And actually, it makes more sense because that's the idea.
Yeah, that is the idea. So we can come in here now and say Control F5, and we got our guy running around, right?
And if all goes to plan...
he
died. Can we shoot a fireball? Oh, we shot a fireball! Woo. It's almost like we remade Evil Monkeys. This is Evil Monkeys 2. The Revenge.
Haha, got you. And did you notice that, guys? He actually blocked our missile.
He dodged it.
He dodged it.
That's just a happy accident that comes with our AI code, which is really nice because, of course, the enemy is looking to see if the space is occupied by anything.
Right.
And, at that point in time, it was. It was occupied by fireball, believe it or not. So it moved. So it's kind of nice.
So with that's everything.
That's it. So with this, let's go ahead and bring Photoshop back up.
Photoshop. All right.
So here we are, all the way back to the beginning, if you will.
The beginning of time.
And at this point, these blocks should mean so much more to everyone, as long as they've gone through all of these lessons, of course.
That's right.
Now, it may have seemed like we've just thrown so much stuff out at everyone.
And we sort of did.
Because we did.
Yeah.
But you know, if you've watched it a couple of times, at least once, and tried to follow along, or maybe once without trying to follow, then once with trying to follow, and then come to the end, trust me, because that way you just kind of listen to it the first time, it just kind of settles.
Right.
And then you go back through it and you're actually doing it.
Yeah.
That really does seem to help.
Yeah.
And then take a look at the big picture now. Well, everybody should be intimately familiar with the game, the level, the sprite, the draw engine.
Yep.
And then from the sprite, if one of these guys down here,
The inheritance flow, yeah.
from the sprite, we got our enemy, our character, and our fireball. And then we took character even further with the mage. You know, we've been working our way through all of that, pushing inheritance, one of the ideas behind object-oriented programming.
Yep.
And
if you want to take a look at the next little picture,
this should make a little bit more sense now as well.
Or people are right now saying, one more time.
Because we've been going back and forth, and one class is accessing the other class, which has to turn around and access another class, and this should become a little bit easier to manage, to understand, etc. Yeah. Anything you want to add on top of this as a recap, Joel or Dan?
Actually, no. I just hope you guys actually know what all went on.
Yeah, I hope that everyone enjoyed the process. Because it was a little bit complicated.
This is tough, yeah, because we're trying to get... It's no longer small concepts.
No.
This is a large concept. And this, while it's a large concept now, will become a small concept with some of the things we're going to do in the future.
Right.
At least that's the plan. As long as we still have people that are watching the videos. Everybody doesn't die.
Yeah.
So
we don't want the audience to die.
This really will conclude this VTM.
Right.
Now we're going to throw a bonus lesson out, which will be coming shortly, where we're going to show you how to take this game right here and port it to Game Boy Advance.
Right.
Now, I've been talking with Dan, and I can get the word actually in there at least once.
Actually.
Been talking with Dan, and I've been talking with Joel about the idea of getting into OpenGL and DirectX and looking at using this game right here so that we can really show you how nice it is once you've got a game set up so modular like this.
That's right.
Where we can take the draw engine and just bloop, make it OpenGL, and we can start using some really cool graphics so that suddenly our game, which is the same thing, looks really cool.
Yeah.
Right? Because it's going to look that way on the Game Boy Advance because we've got to use sprites, not our ASCII characters.
Yeah, that's right.
So that's going to be no fair that suddenly it's cool and, well, we're kind of not so cool
Not
here.
so cool.
So I think we may push for that coming up really soon. And, well, we've got tons and tons of stuff to do, but this is a really cool first step into game design in general. So with that, as I did at the beginning, I'd like to do here a huge thank you to both Dan and Joel for your time to lay this out, develop it, to battle one another back and forth.
That was fun.
Which was great.
It was fun.
Zach and I could just get some popcorn, kick back, and watch you guys for hours because it was just a challenge of the minds. No, mine's better. No, mine is better.
Then argument that, you're right.
So that was great stuff. But, it's been a long journey, and here we are at the end. So, again, a big thank you to both you guys. You did a fantastic job.
Oh, thank you.
Thank you.
And we'll also throw this out there right now, though it may not be super appropriate, but we'll throw it out there again a little bit later. But a thank you to Demondo.
Yes, thank you, Demondo. You're the one.
Demondo is going to be the one, in a sense, responsible for the whole Game Boy Advance port.
Yes.
Because he gave us the required stuff.
Yes, the hardware.
The hardware that we need to hook it up so that we can give it our game.
That's right.
But we'll talk more about that, and we will thank Demondo just a little bit more when we get into that bonus lesson, if you will. So with that, that's going to wrap up the first VTM that covers basic game design. Thanks a lot, everyone. Take care.